Please proceed, Paul. I'm ready to go.
All right. Welcome, everyone, to our program today on statistical literacy. I am very pleased to introduce to you Dr. Juana Sanchez. She's on the faculty in the Department of Statistics at UCLA. She's been there for the past 10 years. One of the innovative projects she has been involved in there is the Statistics Online Computational Resources Project, also called SOCR, S-O-C-R for short. It's a great set of tools that are freely available to people to use in teaching statistics and probability. She's currently the director of the International Statistical Literacy Project of the International Association for Statistical Education. As the director, one of the programs she has initiated is an annual International Statistical Literacy Competition for school students. Today, she'll tell us about statistical literacy for the 21st century, data handling, and chance activities to help students prepare for and participate in that competition. As she goes through her presentation, please feel free to ask questions at any time, be as involved and active in the conversation as possible. So, Dr. Sanchez, please tell us about this program.
Okay. Thank you very much for allowing me this opportunity to talk to you and to all the participants about the literacy competition. As we have, first of all, I want to tell you we have, of course, a website where all the materials that you're going to see here, and not all of them I selected, but there are many materials to practice for the competition to give to your students. So if you go there, you can also register for the competition on behalf of your students. Okay? So I will just go ahead and start with my first slide to establish my philosophy, or more or less the philosophy of the competition, which is that you have to have students involved in the whole data cycle to help them become statistically literate. And what I mean by that is not just limit the questions to specific little items, but as much as possible in every problem, try to bring together the cycle of data analysis, which is basically the cycle of scientific studies. You start with a question, make plans on how you're going to answer the question. So, for example, let's say the question is, how far do giant gummy snakes stretch? All right? If that's the question, how are you going to answer the question? Well, you have to plan how are you going to measure the stretch of the gummy snakes. Are you going to use a ruler? What kind of tape will you use? Are you going to be concerned about the initial length? Should we consider also taking into account that women might be measuring different than men and things like that? So start thinking about all the possible variables that might be involved, and then collect the data. And in the collection of the data, you might decide whether are we going to collect our own data, or are we going to go and find data on the internet from somebody that might have done this problem, so primary or secondary data. Then how are you going to analyze the data once you have it? What kind of graphs are appropriate for each type of variable or for the relations we want to study? And then the conclusion, and also this conclusion does not necessarily, particularly in the competition, we're not going to expect middle school kids to do formal inference, like formal conclusions, but they can establish descriptive level conclusions and make some predictions based on those conclusions. So prediction will also play an important part, and then based on that, discuss further. So the whole data cycle is something that we would like to emphasize. And the training materials don't go straight to the whole thing, but you see that they're all involve data in some way, whether the data you collect or the data that other people have collected and interpreted, and how they've done it. So the competition is an opportunity for students to show how much they know about this data cycle, and the final is going to be in South Africa in 2009. We use mostly resources from the countries of the children, and if they're not there, we build them. For example, in Portugal, We could not find any place. Portugal did the competition last year. It was a pilot. And at that time, they did not have, for instance, activities where there were newspaper articles with active drafts that students could go and criticize and so on. So that got started this year so that we could have it for the competition this year, because the United States, the English-speaking countries, have access to a website that has a lot of these things prepared for school children. And it will be unfair that the United States has it and the other countries that are competing don't have the same resources. So Portugal is creating that themselves, and so on. So most of the frame materials then are selected from these participating countries, particularly in their language if possible, and if not, we translate some things. Okay? And the phases of the competition are 3. There is going to be one in school. After the teacher registers the students, there will be a phase in the school. It's our first very international competition, so we are not very rigid. We're allowing different dates because there are 2 hemispheres, the north and the south, different school years. So we are the first and the second phase. We are very flexible, but we want everything to be done before 2009, of course. So at school, we'll send a question that will take 90 minutes to answer. That will involve the whole data cycle, interpreting data, and so on. And the students will do it in the classroom with their teacher. Then the teacher sends us the material, and we grade it and select for each classroom that the teacher has defined for us. We select a winner. Then those winners will compete nationally. In the United States, for example, it will be easy to do it online. We would rather do it in a conference, but that, of course, everything depends on volunteers and resources. And if it's volunteers are very important. So if we don't have volunteers organizing the conference, then we just do it online. In other countries like South Africa, that's impossible. So the competition will be done with very strong cooperation by the statistical office there, and they're going to organize it in the different provinces and so on. And the national statistics, and the statistics office also. Hold on, I'm mixing the statistics office and the South African Statistical Association. They're working together, and their national will be next year in the national conference of the South African Statistical Association, which is a great group also. So it all depends, but then the final will be in South Africa, and this is going to be a wonderful event because they're really, really preparing for the International Statistical Institute biennial meeting, and the children are going to play a very important role. So for South Africa, this competition is very important because it's going to bring kids, and that's what they want to have around during it. So, and they are preparing a lot for it. So the students category will depend pretty much. Countries have curricula in statistics. Many countries do. We all know that many countries don't include statistics necessarily in the teaching. The curricula is there, but that doesn't mean that it's being implemented. But nevertheless, as guidelines, we'll go with what is the middle school in a particular country. So we will expect that level for the kids for the competition. Although the teacher should tell us at what level the students can compete.
Bye, Bethany. See ya.
Yeah, we should expect that. And then the ages will be 10 to 18 years old, and it's free. Everything will be free for the kids and for the teachers. If you have any questions about these details, logistics details, before I move on to illustrate the activities, let me know. These are all rules of the competition, what I just told you right now. Any questions?
Oh, let me say this. The data detective graphic that you had at the front, I thought that was a great graphic.
Well, this graphic is made by Statistics New Zealand people, and they run the census at school for kids.
Right.
And this is the posters they give to the schools.
I thought so. That's super.
Yeah, it's not ours. As you can see, there is a lot of logos here. These are not our logos. The little ones, it's hard to see. But that's what they use to give the teachers when they do the census at school activity.
That's
very pretty. Yeah, it's very
simple.
Where is the graphic posted on the web somewhere?
The graphics?
Yes.
Yeah, the graphics is in the, if you go to University of Auckland in New Zealand. Yes, University of Auckland, A-U-C-K-L-A-N-D, University of Auckland, a statistics department. They have census at school there, and you can, I can mail it to you if you want, I have it, but,
that would be nice.
yeah.
I just did it in Google. If you put Statistics New Zealand Data Detective, you'll get it.
Yeah, exactly. And they have two. They have an older guy and a younger. I put here the younger because the activities today are more for younger people.
Links, that would be great.
Pardon?
If you can email us the links, that would be great.
Yeah, I will. If Rebecca gives me or I'll send it to Rebecca, and Rebecca can mail it to you. What about that, Rebecca?
That sounds good. I'll do it.
That sounds good? Okay, I'll do that. Let me write it down, otherwise I'll forget it.
On chat.
Yeah. I used it last year in a school here in the United States, in California, and the kids loved the poster more than the activities. It was much better. But yeah, the Statistics New Zealand has Statistics New Zealand, no, the University of Auckland, the Census at School project has lots of activities for teachers, and they're ranked by grade and all that too, so you can also look at that. Anyway, so any other questions? If you don't have other questions, I'll move to go through some of the activities. So I was thinking that perhaps, and I put that on the training package that is posted online, we put some questions that to encourage the kids to see the finish line. They always tell athletes you should look at the finish line, right? And that way you know where you're going. And they should start by learning where they're going to go, as if they were going to go. They're going to win, right? So the place is going to be Durban in 2009. That's South Africa. That's a map of South Africa and its provinces. And it's going to be in the region of Kwazulu-Natal. And here are the hosts, some of the hosts. Of course, it's the South African Statistics Association. It's also going to be a host. But these are the main organizers, the Statistician General. These are South African teachers that they brought last year to Portugal, and these are the people organizing the IASE Valo program, and the competition is going to be part of the IASE Valo program. So these are the first, and they have offered already a prize of a scholarship to the winner, and they're very generous. So I can say. So anyway, a way to start introducing the students to correlations and relationships between variables could be a good way, showing the map of South Africa or the United States, but we are into the finish line right now. Showing them, for instance, I chose a variable like what percentage of people of this age are not attending an educational institution, and the darker, everybody can associate with color, so the darker ones means that's the highest. But obviously we can see that this part of the country is darker, and then we can see that this part of the country is also darker in terms of disabilities, more people with disabilities on this part, and that's the part we're going to visit. So what happens is that because it seems to be a relationship between disabilities and not attending educational institutions. So this is darker, this is darker, these are lighter. So imagine if you have ever seen a scatter plot, you can see what the scatter plot is going to look like, right? It seems to be a relationship, a direct relationship between these two variables. So that's a very nice way to discuss correlations. You put several maps here and see if it seems like the areas in which there is more, is darker, are the same areas correspond to higher values of another variable too. And the kids early understand that. So another thing you can do is talk about the population, practice doing a map by using the population figures. And this is just a survey they conducted recently. And they just make the kids, for example, put the percentage change in population and color it instead of making it put the number, but also color it and see which areas grew most. Kwazulu-Natal obviously is not one of the highest, but it's not one of the lowest. So which are the darkest ones and which are the lowest ones, the lightest ones. And then ask them which province grew the least and practice along the way with the percentages. How is this percentage computed? Okay, the statistical literacy is very associated with numerical literacy, so go with that along the way. And, along the way you can see the data came from census, and another data set came from a survey. So it's a good opportunity to discuss with the students the difference between a census and a survey, and maybe play in the classroom, do a census of the class. And there are two websites that are very nice for that. One, I think the audience today is Canadian and U.S., right? So I would recommend the U.S. Census Bureau Data Kids Corner, and then the Statistics Canada Power from Data area. It talks about these things too. And then you can look at more things. So what kind of people live there? What do they have? Well, this graph shows what percentage have radios, what percentage have television. And the kids immediately can see that there is very small percentage that have computers and very small percentage that have internet. But the usage of cell phones has grown up a lot. So this is not a statistical graph per se. It's not a distribution, but the students are going to see a lot of this in the media. So it's good that they practice comparing. This is telling us the percentages in 2 different years and compare. And then further, you can ask, well, is South Africa become more or less like the United States, and why? Well, they've got more cell phones now. They are decreasing the number of landline phones. They are increasing the number of refrigerators. More people have televisions. More people have radios. So, yeah, we all have radios and televisions here, so they're more like that. And then another question might be, how many households have computers at home? So that would be a more numerical question. How many households? Now, the students might be inclined to go and say, well, all I have to say is multiply the percentage, right, by the number that I have here, the population. But that wouldn't do, right, because the percentage will have to be computed over number of households. And I'm not giving you here the number of households. So the students will have to go to the internet to find the number of households and find the document where it is. So that's also an internet activity. And then more in particular, the area where we're going, Kwazulu-Natal, how does it compare with the rest of the country? So here is the same information, but for households in Kwazulu-Natal. And we will have that information after they find the number of households in Kwazulu-Natal. They could do a similar graph for Kwazulu-Natal, okay? And compare that graph with the national graph. And it's not hard to see that they are pretty much same percentages. And in this way, they can practice doing bar graphs and realize they have to put the same. Here, if this goes from 0 to 80%, here it should go from 0 to 80% to make the two graphs comparable. So it allows to play with the graph, and at the same time, the students realize the importance of having graphs that can be compared and not be fooled by graphs, so on. Anyway, so any questions so far about this activity? Another thing you can say, well, how does Kwazulu-Natal fare in terms of household? Well, it doesn't look, the percentages for each of the items is the same in Kwazulu as it is in the rest of the whole nation. That would be just introducing, and then you can come back home and say, well, are we here in the U.S. very different in these things? And that's when you include your class. You do a census of your class. Or use U.S. maps, whatever you prefer, instead of doing it with South African maps. And ask the same questions, and then ask your students to do a bar graph. And for example, you collect the data. You ask them these questions. You collect the data. Your data set might look like something like this. I did this in a classroom. I didn't ask them about refrigerators. The kids didn't care about refrigerators. But they didn't care about pagers either, obviously. But MP3s and things like that. And your data set might look like this with an identifier here on this column. And then make them summarize this data set. If you have a small classroom, they can do it by hand. And they can give them the template. And put I was going to write, but let's say you, well, I have something better to write. So I can figure it out. Just do one graph. Calculator, for example. Okay. I counted how many, the percentage of students that have calculators. So you can just do a little graph and just tell them, well, you see this you can, how much was that? It was about 86%. So if you should put first where your 100% is, right? So let's say your 100% is here. Not very good at it. So it's 100%, right? And that way they can do their own graph and play with it. It's like that. Anyway, so not so much with graphs and maps and so on. So there's a lot of activities in the training package that we put together for these, and the next ones there will be a lot of graphs to play with and tables from the graphs and so on. Any questions so far about this?
I think you're right, Juana. The use of graphs is just vital to gaining statistical literacy, especially since, as you said, they're going to see them so much in the media and around them and the things that they read.
Right. You have a section about media later on, too. So, and how misguiding graphs can be for the kids. So if they know the whole data cycle, you collect your data, you graph, they can put themselves in the minds of the people that are presenting the graphs to them through the media or through books, and try to go through the process and figure, well, what did these people do to this graph, and why did they get it so wrong, or why did they get it so right? And without knowing what goes on, you have to collect the data, you have to put it together. The graphs are very mysterious to the students. So anyway, for your learning, you can also, the same thing about your class, you can collect that data set, do a census of your class, and then collect data about things that matter, like pressure from school, how they travel to school, how much time it takes them to go to school. And then you can make them do graphs. Depends on the level of your class. I did the pie chart in some places, and then it's hard for kids to draw the percentages as areas. So before they do a pie chart with the technology, which they should learn to do, but then they should also do it by hand to appreciate that the percentages can be represented by area. Since this is a little harder to use than just giving them a whole pie, empty pie, and they can put the percent count from the data, how many of the students felt just some pressure and so on, and come up with a very nice pie chart. And then, but the question that we are asking is, does pressure, is the time that it takes to go to school affect pressure? So we have two variables. They play with quantitative and categorical variable. And for instance, these guys here, the average time for the ones that have no pressure is 29. And then for the other ones, it's like 28. And if you keep taking the average, and this is the arithmetic average of the group, of time for the group that said no, you see that for most of the groups, there's no difference, the average time they take them to school. So there's not much relation really between average time and pressure. And but all it takes, the students have to count. What if we are trying to figure out the relation between the means of transportation and the pressure going to school? I'm forgetting here that there was one student that uses a skateboard to go to school. So this person should have been here too, the skateboard, and counted. So you count all the students that are here and then try to see if there is a relationship. And here it's harder. You have to introduce a little bit the notion of proportion. These 2x2 tables are harder for middle school students, but find the total proportion here, compare the proportion relative to this population. So that's involving conditional probability, proportions, and so on. And it's a little harder, but it's a challenge for the students. They should do things like that too. Okay. So for your class, I recommend for a medium, intro classes, intro level. The lowest level activities involve a lot. Look at the data, summarize it, do a graph, interpret it. Okay, ask the question. We give the question for the most part, and the students will do it. Any questions so far? No? Should I go on?
Please.
Okay. So there is then activities to interpret the analysis that others have done, right? So there is the media. This just came in the New York Times not too long ago. This involves counting, right? So students can count pretty much how many tons of manure cows produce in terms of the number of cars and the volume of the cars. So here it says 14 tons of manure is the same as having the weight of 10 cars and things like that. This was actually, but the most interesting thing might be for the kids to count how many gallons of gasoline did they eat today, really, if you look at the equivalent between how much energy it takes to produce the food they consume and so on, and ask all your students to make an estimate of that, and then collect the data and say, well, how come there is so much variability? Because each student is going to consume different number of gallons, and come up with possible explanations, other variables that might explain why their consumption of gasoline is so high or so low. And so the idea is ask them that and ask them to estimate it and put together a data set. And again, it's the whole cycle. Have a question, make them come up with the data. You help them put it together on the blackboard, and then, again, if you have a small class, of course, if not, use technology right away. And then ask why each of you is so different, why each of you are so, without getting into personal questions, why does this one have so little, and then is it because your family, might come, an ethnicity might come up, culture, many factors, okay? So you might want to read the original article, it's a reference, but there are, as I said, there is a website that contains articles. Unfortunately, all the articles are from Australia, and students don't like to read too many articles from other countries. So it's good to find your own articles, and we are trying to provide some to the website so that teachers can use them also. So the question that come up after looking at the data, which student is the more energy efficient, is helping the environment more than others, And you can bring ecology and environmental issues by this activity, by finding out how much gas they eat, and bring other discussions to the classroom. But always looking at their data set, because it's very important. And then also train them to see where are bad graphs. Bad graphs, for instance, this is a graph that I'm going to show you now that is trying to show how much Australia changed. Again, this is a graph from Australia, that Australia website I told you about. And let me give you a quick take at it. This is trying to show how much the country changed. But they just jumped together on these side-by-side bar graphs. This is before, the light ones, this is after. But in the same graph, they have put together percentages change. So this is a percentage before, percentage after. But they also have put averages, arithmetic averages. They have put together any numbers. So the thing is terribly hard. And then they write an article that is equally jumped with mixture of statistics, summary statistics like X-bar and means and proportions. So it's very hard to understand. So another activity you can do is ask your student to convey the same information differently, so that it's a little easier to swallow. And that would be something that you could do one day in a class and say, how would you say the same thing with a nicer graph? Huh? I don't give you the answer here, but because one of the things we have in the competition is we don't want to force there is not unique graphs. Students might choose to do a nice pie chart, a well-built pie chart. If there are very few categories, they might want to do a bar graph, or side-by-side bar graph. I want to do stack bar graphs. It's not a unique answer, so there are possibilities, and there are very creative graphs out there too. So as far as information is conveyed properly and clearly, and there's no ambiguity, it will be accepted as a good answer. Huh? The same, this is also from that Australian website, and measuring the country by percentage of women in parliament. The girls get interested in this one, and then making them compute the regional average. But from this one thing you could do is make them realize that although the quantitative variable is a percentage, they can do a histogram after they read the article. And the histogram summarizes where most countries stand. Most countries are somewhere between 5% and do the process of, because there are so many bar graphs, right, that we have seen, you also want them to be doing their histogram with quantitative data. So how many countries have between 0 and 5% women in parliament? How many countries have between 5 and 10% women? And then they get this picture, which is not very pretty, but they can say, well, most of the countries are between 5 and 25%, but see, some countries are pretty high. And then they can look at where the United States is if they're interested, and so on. But the point is to show a way of conveying information in a different way so that they can see how would you write this article differently. And of course, every time the students do something, they should write. They should always write, because the competition is going to be, you do, but you have to write. And we are going to read the write, and we are going to read how they put the story of the numbers and the graphs together in a nice way so that conveys the message most clearly. So writing is encouraged a lot.
Juana, can I jump in and endorse that? That is an absolutely essential part of it, in my view. As you say, they have to always write something. In my view, writing is learning. That's when it happens. Is when they don't see it or hear it, but they actually have to write about it. The thought processes are clear. They understand. They can express it. That's what's wonderful about your program. And that writing part, not just making a poster, but writing about it is essential.
No, it's very important. Yes, thank you for encouragement about that. But it is important because they're going to be communicating a lot through writing in their lives. They're going to be working for somebody or for themselves, but they're going to have to convey messages, and more with graphs and with visual information, with their explaining the information to others, and it's part of being a statistically literate in this society. You cannot work if you cannot show that you can explain things better than somebody else. Because everybody's on a fast pace, and they all want to see it fast. And well done. Any questions about the media interpretation is a very important part. So let's say we haven't put together yet specific questions for the competition. So far we're putting on the website the pieces, and as thorough as possible, but pieces to start training. But the third package is going to have questions like not exactly, they're not going to be those questions, but like the ones in the competition. And in those questions, there is always going to be not just you look at the data, but maybe how you looked at it, you analyze it this way, but now look at how somebody else summarized something similar. What do you think about it? I know in 90 minutes there's so much you can do, right? But for the first part, the second phase might be longer. But that would be also interpreting what others have done. And again, if you know the data cycle very well, you know what goes on from the moment you ask the question to the moment you reach the conclusion, then you can ask the right questions when you read that newspaper article or the report from somebody, and see what might have gone wrong along the way, in which of the steps of the detective is not done well, no? And ask the right questions. So what I was going to say is, there is the questions on analyze data, do the whole cycle, the question of interpreting other data, but then take the opportunity anytime, if you're going to train your students, take the opportunity anytime during the class, whatever the class is across the curriculum, bring something up. For instance, I have here a few little activities that are not comprehensive, but might keep the kids busy for 10 minutes, and ask them, for instance, judge a graph. Here is a graph. So just ask them, what information does this graph give you? And train them. Graphs have to be labeled, right? This graph says nothing because we don't know what's here, we don't know what's here, and we don't know absolutely anything. What's the label? We don't know what the colors mean. Well, we have a title now, how 11, 16 years old traveled to school. That's better, right? This is better, no? We have numbers, we have categories, but we still don't know what the colors mean. So, again, we cannot interpret anything. And finally, you have this is an Excel graph. It's a bar graph. I preferably avoid these graphs I avoid these graphs everywhere, but I avoid these graphs in my in my classes, but I avoid them also in the questions for the competition because I prefer the students get used to using percentages. If we are going to compare these, and comparison is very important in this competition, compare this group with that group. It's important that they have percentages here. So this graph should all have the same height in terms of percentage in the category. Is these numbers, instead of numbers, the percentages should represent the proportion among those who walk that are ages 11 to 16, the proportion among those who go by bus that are this age, and so on. And so that you can see the dependence, the relationship between the two variables. You can see it here, but it's not so clear as when you put it in percentages. And that's to encourage everybody to use those. Anyway, so that's one thing. The other activity you can also that you can throw at them is dirty data. I mean, part of the cycle of the data analysis is the data cleaning, right? Collect your data, but if you're collecting data in a class, some kids might have decided to play a joke, and they may just say, well, I'm just going to put whatever I want there. So the kids who read the data and make sense of the variable. If it's boy or girl, why? If we allow for neither, or if, let's see, what's the other one? There was one crazy one. Okay. Born in, this is data from England. So if you born in Planet Zog, is that a country, you know? Well, so obviously this is a mistake. And what are we going to do with this, you know? The height is in centimeters, right? So how can somebody be 14.2 centimeters? Right? So the kids should learn the problem of data. Data could be dirty, and it needs to be clean. And if you do analysis with dirty data, you're going to get crazy answers. And so this process also needs to be part of because it's also part of literacy. They should ask themselves when they see something in the media or in reports, they should ask themselves, well, could this have been caused by maybe a data entry error? And we all know very well a lot of scientific studies have been invalidated because they had data entry errors. So at least the kids should be able to ask themselves that question and know that it's possible and know how it might look on the data to have a mistake like that, and so on, right? So other things like, well, 3,000 kilometers distance to school, that would not make sense either. So that would be, it's kind of funny for them, but brings the point, right? Another thing on interpreting crazy graphs, right? If you're measuring the pulse rate of 6,700 children, and okay, you may not know much about physiology, but a pulse rate of 401 to 500, so we're counting the pulse rate of dead people too, or what? Because people will be dead with that pulse rate, right? So the kids should be able, when they see something like this, say, well, that's impossible. This is not even extreme person here. It's just it has to be a mistake. Or do we have zombies around now, or what? So seeing this graph here, this should be, the stars should be together. Again, I picked up this graph from, as I tell you, all these resources come from somewhere. These come from England. And they all in our training package have the reference of where they come from, if we did not create them. And so you can see that students can start realizing this is impossible. What do we do with this data? Should we remove it, and so on? Anyway, other items, well, like summarizing groups of sandwiches by calories. It's always take the opportunity to introduce things that affect their lives, because that's where the literacy is going to come in, things that they read around the things they do every day. Like maybe go to McDonald's and compare the calorie average of different types of sandwiches. Okay, different questions. What's the range of calories for one? And start introducing summary statistics, because at middle school level they should already be familiar with computing these numbers. Not just give them a list of numbers and say find the mean, but put it in a context of things like this that they might do every day. But they're in the 6 chicken listed from McDonald's and so on. And so what's the range? They introduce range, introduce the median, they start introducing these summary statistics, and they start discussing them. The first training package doesn't have activities yet in which the kids will decide what kind of summary statistic to use yet. Another thing you can introduce is the water issue. Water is a big problem in many countries. So how much water do you waste just washing your mouth? So ask them to bring data to the class and ask them to measure the number of minutes it takes them to wash their teeth with the tap water on, and then take a little cup and measure how many cups you can fill up in that minute, in that amount of minutes, and then bring to class how many cups they use a day for washing their teeth. And then see how many, and put all the data together for each kid. You have put it on the blackboard, number, and order them and ask the students, why do you all differ so much in the number of cups of water that you consume? Okay? And if everybody used the same amount of water you use, how much water would be used in all LA just washing your teeth, and so on? Bring up the bigger picture later on. But first, their picture, first summarizing, on average, this class, how many cups of water it uses. And then identify the ones that don't probably wash their mouth much. That would be mean. But no, the students might bring it up, right? Well, we vary so much. Variability is so big because some of us don't wash our teeth, or because our mother doesn't let us have the tap water running, and so on. So it brings a lot of discussion, okay? And then finally, they do a lot of experiments. Like at the beginning, I told you, just for the whole data cycle, do some experiments that like the gummy ones. This gets people very involved. Take parts of giant gummy snakes and make them measure, several of them, and keep track of the data. And the initial measurement, how much did they measure before we stretch them? How much did they measure after? Because, of course, you need that baseline measurement. Otherwise, they can't do the experiment, right? They cannot. The data is not very good. And then also take into account who is doing the measurement. Is it sex, male or female? How much did it take to? What was temperature like? And at the time we did it. So introduce multivariable data. The measurement before, the measurement after, the sex, the temperature, other things. That amazing how many things the students come up with when you do this experiment. They just have variables more than you can use, and count those. And maybe you don't get to analyze the data, but you have introduced to them the notion that to do an experiment there could be many factors, and if you don't want to have so many variables, maybe you should just control and keep some variables for everybody constant, right, so that you don't have so many things to have to take into account by the time you get to reach a conclusion, and at least get started. So these activities that I mentioned so far are not very mathematically involved yet. They involve summarizing data in some way. They involve time graphs, they involve summary statistics, but they interpreting media. But they are showing the main ideas of statistics, variability, summarizing, reaching a conclusion, and it involves things that they usually are very likely to. Some of them, I don't think they'll have to deal in their life with gummy snakes, but this experiment will allow them to be more critical to experiments they hear about in the media also. So it's by doing that they will become. The second set of training package that we'll put on the website will be a little bit more involved. But I think, planning how you're going to measure, what kind of ruler, all that stuff. So I think I'm done pretty much with my presentation, so you're welcome to ask any questions.
Juana, thank you very much for that.
Welcome.
I certainly agree with many of those points that you brought out. For example, the dirty data. I think too often students in all levels of school only see clean data. They don't know what dirty data really is and its impact. That's a very important exercise for them to go through.
If you want, any of you want, I can go more in detail into, I didn't want to make this too long. I can go in detail into any of the activities I've looked at. But if you are interested in the packages, the training package put on the website, plus all the links that we put there to material, that similar material that you can find on the website for training. And some of the materials are already have they don't all have the answers, but they have suggestions for the teachers and so on. But again, you can do it many ways. And of course, I can answer any questions you may have. Some teachers just email me and ask, well, I'm not used to doing such broad questions, you know. Question that teachers often ask is, these questions seem very broad. They're not asking specifically compute these, right? They're asking me a question and I have to do many things. So one good strategy, I think, to train for the competition is to start with these small things like those looking like what Paul said, the data, collect a little bit of data, the water data, and talk about water problem at the same time. So students don't see statistics as something that you do from 4 to 5 every Monday, but as something that you can bring up anytime. So you are sort of teaching them in some way. You're bringing the data into their lives without calling it statistics yet, but you are making them aware of variability. Why are you all so different? How can we make this small, summarize it in a number or in a picture? And the students get the feeling that they're not doing statistics. They don't call those things statistics or math, but they are, because the lowest level of, it's the most basic level of statistics. But that's the point. Start with individual tasks and do several little things here and there along your curriculum, and then once in a while do a major. Okay, we're going to do a census of the class. We're going to do a survey of the class. What would be the difference between the two? And then at that point, it's more formal, right? We have to collect the data. We have to do it more like a ceremony. There's the census, the questionnaire. We're going to summarize it now, and so on. It's a little more formal. But so that's what I suggest to teachers, instead of feeling, oh my gosh, it looks like I have to be analyzing data all the time. Yeah.
Your examples and the things that you put together are marvelous, because, as you say, those are things that affect their lives, and when we want to make the cognitive jump to focus on, well, what does it mean, how do you interpret it, we want them to develop critical thinking skills. They could only do that in the context of their experience in their lives, and so these examples are just marvelous, Juana.
Thank you, Paul. So you can, if anybody, my email is in the website of the International Statistical Literacy Project. You can find me also at UCLA. My Department of Statistics, you can Google me and find me easily.
Juana, let's go back to the first screen where you have your website shown there.
Mm-hmm.
Yeah.
Oh, well, in the final competition, and that's why we include these questions, it's going to be geography, statistical questions embedded in some kind of geography, comparing countries. That will be part of the competition. So there we go.
There's that great graph, and there's your website. Okay.
Mm-hmm. Yeah, but you can Google me if you forget. Find my name, just say Juana Sanchez, or UCLA Statistics Department. And there's a directory there, and you can ask a question. If you need more materials too, we're glad to refer to. Of course, you have the American Statistical Association there. I'm just talking about specific questions about the competition, because of course, for anything else, like they say, if there is no MasterCard, there is the American Statistical Association. So it's they have a great. We use resources from them too. Okay, so there's lots of resources from the Center for Statistics Education run there. So for the teacher network, the Statistics Teacher Network, the magazine, it has very nice examples too. And most of them also is in philosophy, data analysis, and make sure you look at data in so that to show the concepts in an informal way first, before you get to the math and the formulas and all that. Okay, so
I particularly like your example of graphs, like doing in percentages, just not in numbers, because that could be very misleading.
well, excuse me, I cannot hear you very well.
Oh, I said I particularly like your point about doing the graphs in percentages rather than in numbers, because for the reason you stated, the numbers can be very misleading.
Yeah, you need the whole always, and more than one number if you have numbers. That's true.
Yeah.
Anyway, so whenever, if any other questions?
Juana, thank you so
Comment?
very much. We appreciate
Okay.